So please let me know once you're able to see the screen.
Yeah. I can see your screen, sir.
Visible now?
Yeah.
Okay. Okay, today we'll do geometry. We'll start with basics and build it up.
Mm-hmm.
So some concepts related to angles. So two angles are said to be complementary if their sum is equal to 90. So in this diagram, A and B are adjacent angles and their sum is 90, so they are complementary to each other.
Yeah.
So the angles have to be adjacent to each other. So that is the precondition.
Yeah.
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 Similarly, there's a concept called as supplementary. So two adjacent angles are said to be supplementary if their sum is 180.
Yeah.
Push me. Yeah.
Yeah.
Simple concepts. Okay.
Mm-hmm.
Now there's a concept of vertical angle, which is basically opposite angles. So
Mm-hmm.
we have learned that so L1 and L2 here are straight lines. Okay. And by the law of supplementary angles, which we just learned, can I say A plus B is equal to 180?
Yeah.
Also, B plus C is equal to 180. C
Yeah.
plus D is also 180. And A plus D is also 180. All these are supplementary.
Yeah.
The angles which are formed opposite to each other are equal.
Mm-hmm.
Like A and C are equal, and B and D are equal.
Yeah.
So these are the vertical angles or opposite,
Mm-hmm.
non-adjacent.
Yeah.
And all these supplementary angles are basically adjacent angles, creating a straight line.
Yeah.
Yeah. Okay. Next, there's a concept of corresponding angles. All these are related to angles. Another concept. So your L1 and L2 are parallel lines. L1 is parallel to L2. And there is a line which intersects this system of parallel lines, which is intersects L1, L2. So that line is L3, and that line is called as a transversal. So what is a transversal? It's a line which intersects at least two parallel lines. So the rule is that whenever transversal intersects this system of parallel lines, all the acute angles formed and the obtuse angles formed are the same, which means acute angles are A, G, C, E. AC, which are also vertical angles, opposite angles, and EG, which are also opposite angles. All these will, since these lines are parallel, A will be equal to E. So since L1 is parallel to L2, A will be equal to E, and A is also equal to C because they are opposite angles, and E is also equal to G since these are opposite angles. So entire system of acute angles are equal. So AC, EG are equal. And similarly, since the other angles, which are obtuse angles, are supplementary to all these, so clearly 180 minus A will be equal to 180 minus E will be equal to 180 minus C will be equal to 180 minus G. And hence we can conclude that B is equal to D and B is also equal to F and F is equal to H. So all your obtuse angles are also equal.
Yeah.
Yeah. So as simple as this, diagrammatically, if you want to see better, this is a transversal L1, L2 are parallel lines. So all these angles are equal. This is equal to this, is equal to this, is equal to this. So these are the set of obtuse angles. And all the acute angles are also equal.
Yeah.
Yeah. All right. First question. Find the measures in degrees of angles GEF. GEF, which is this acute angle, and DEG, which is the obtuse angle. So clearly these two angles are adjacent and form a straight line, which means their sum should be equal to 180. Which means 2x minus 40 should be equal to 180. So x should be equal to 110. So one angle is 130 and the other angle is 50.
Yeah.
Yeah, simple,
Yeah.
supplementary. Many problems can be solved using complementary and supplementary rules. Even when we go to triangles, many of the rules are applicable there. Now, what is the degree measure of angle, second question, of angle PRM shown? So PRM is this what they're asking, which is the obtuse angle, more than 90 degrees. And So what is PRM? So can I say the three angles here, 4y, 5y, and 3y are all adjacent to each other and all supplementary. So 12y should be equal to 180, supplementary, and hence y should be equal to 15. So what is the angle of PRM? Total is 8y. So that is 120 degrees.
Yeah.
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 Next, M and N are parallel lines cut by a transversal L. So which of the quantities are higher or equal? 1 plus 2 and 3 plus 4. So what is 1 plus 2?
180.
180. Supplementary. And what is 3 plus 4?
Also 180.
Yeah. So this angle will be equal to this angle because of parallel lines. And hence 4 plus star is equal to 180 and star is equal to 3. So 3 plus 4 is also 180.
Mm-hmm.
So both quantities are equal. So once again, parallel lines cut by a transversal, the opposite angles created are equal. Yeah. And that's
Yeah.
what we are using here. Should I proceed?
Yeah.
Okay. Lines Q and R in the figure shown are parallel lines cut by a transversal P. Q are parallel, P is a transversal. What is the sum of measures A, D, F, G? They're asking about A, D, F, G.
360.
Sure.
Yeah.
So can I say A plus C is 180,
Mm.
supplementary, and C is equal to F. So A plus F is 180. Similarly, the next set is F plus G. They're asking. Yeah.
Yeah.
Sorry, D plus G. Now what is D? D is this and G is this. Now D plus F is equal to 180. Supplementary angles. D plus F. And F is equal to G. So D plus G is also 180. So the total of these two is 360. So we are using this rule here. If this is a transversal, then these two angles, their sum is 180. So that we are using here D plus F equal to 180. Yeah, so as you pointed out, the answer is 360.
Mm.
All right.
Yeah.
Next. PQ are parallel lines. So this is P and this is Q. And what is quantity A, which is X plus Y? And what is quantity B? 180. So are these equal, greater, less, or cannot be determined? I'm going to create a slightly larger diagram so that you can understand. A lot of things given here. So can I say this angle is 120? This one. So this will be 60 degrees, right? This is given to be 80 degrees already. The sum of sum of angles in a triangle is 180, which means this angle will be 180 minus 60 minus 80, 40 degrees. So this angle becomes 40. If this is 40, this angle becomes 140. So this is because two parallel lines and a transversal, their sum should be equal to 180. So that's the reason of this being 140, this angle. So now we know x is 140. Now what is y? So can I say this angle y is equal to 60? And why is that? That's because we have this setup. This is 60. So this also will be 60. Alternate angles are equal in a transversal setup. So y is also 60, which means x plus y is 200. And the answer is A is greater. So not necessarily you will always get a neat answer like 180 or 360. Yeah.
Yeah.
Also on the GRE, if you have say 32.89 and you have 32.9 as the answer, they should be regarded as the same. Because when you do a roundup, this becomes 32.9.
Yeah.
Just for you to note. .01 or 0.001 difference when rounded up will become same. So these two are equivalent answers on the GRE. Okay.
Yeah.
So this is our angles. Another question. Got it, right? So
Yeah.
step by step we go. Whatever we can solve, we start from the top. Because here the angles are given, so we start from the top. So the supplement of 120 is 60. So this angle is 60. We know this one is 80. And the sum of angles of this triangle is 180. So this angle is 40. And then we use the fact that the sum is supplementary for the two angles, acute and obtuse, which are formed out of the transversal. So hence x is 140. Also, the alternate angles of a transversal are also equal. So 60 should be equal to y. So y is 60, x is 140, x plus y is 200, which is greater than 180. Quick summary of this, yeah.
Question.
Yeah.
If I had a difference of 0.5, is that still regarded as the same? Like if I had 32.5
If you
or
can't round it up,
32.6?
yeah, if you can't round it up, then it's not the same.
Okay.
For instance, if you have 32.0 and you have 32.2, then you
Mm-hmm.
can't regard them as the same.
Okay.
Yeah. It's only a difference of 0.01, 0.001,
Mm-hmm.
which can be rounded up to the nearest decimal.
Okay.
So if 32.0 and 32.2, you can't round up this to this. So they are not
Yeah.
equal. Whatever
Mm-hmm.
can be round up, you are allowed to round it up to two decimals or one decimal.
Mm-hmm.
Yeah.
Yeah.
Generally, two decimals is safer,
Yeah.
which means if I have answers like 32.88 and 32.9, I will still regard these as equal because
Mm-hmm.
this can be rounded off to the nearest decimal and it becomes 32.9.
Yeah.
I'm just saying because in the official guide, there is a question where you get very close answers
Mm-hmm.
and they are regarded as the same. So rounding
Yeah.
off, you need to be aware of.
Yeah.
Yeah. All right. Okay, so that was on angle measures, the first part. Second is on interior angles of the triangle. So there are different kinds of triangles. So one triangle in which all the sides are equal is called as an equilateral triangle.
Mm-hmm.
So this is an example of equilateral triangle, the first figure, in
Yeah.
which all the sides are equal. So in an equilateral triangle, this is the way we denote that sides are equal. Just mark them
Mm-hmm.
off.
Yeah.
And also in an equilateral triangle, each angle is also equal. And since the sum is 180, each angle is 60.
Yeah.
Next thing is, uh, so this is the equilateral triangle. Isosceles
Mm-hmm.
triangle is where two sides are equal. So it looks like this, where any two sides are equal. And the corresponding angles will also be equal, which means if these two sides are equal, then their angles, corresponding angles are also equal.
Yeah.
A lot of problems regarding isosceles triangles, you will have to probably draw the height and solve the problems using this height.
Mm-hmm.
A lot of problems involve drawing a perpendicular line from the point, which is the common intersecting point of two equal sides, to the other base. Yeah.
Mm-hmm.
And since these two angles are equal, and in the middle there's a right angle. So can I say even these two angles are equal? Which means H will bisect. So H is a perpendicular bisector
Yeah.
because the angles are same, the sides are also same, and hence the opposite sides are also same. Which means this is equal to this. So it's the perpendicular bisector.
Mm-hmm.
It's perpendicular as well as bisecting the
Yeah.
angle as well as the opposite side. Also, if two angles are equal, the sides opposite to them will also be equal. So if I tell you that there are two triangles like this, and you know this is x and you know this is x, so these two sides will also be equal. Yeah.
Yeah.
Only in the case where there is congruence. So there are two. Okay. So let me explain this. This is important. Now, I told you one rule in which I said if the two angles are equal, then the opposite sides are also equal, right?
Yeah.
This is only possible if you know that one of the sides are equal of the triangle, which means here we are talking about congruence concept.
Mm-hmm.
But I could also have a figure which could look like this. Both are x, but this is not equal to this side. So clearly, even this is not equal to this. So here,
Yeah.
rather we use the concept of symmetric concept. Yeah.
Yeah.
So congruence means equality in sides, which is important.
Mm-hmm.
In symmetric, we are not talking about equality of sides. Although the angles are equal, these two angles might
Yeah.
be equal, but it does not guarantee that the sides are equal. So congruence means angles equal and sides
Yeah.
also equal.
Yeah.
Symmetric means angles are equal, sides not equal. So example of two congruent triangles is this. Where this side is equal to this side is equal to this, and the angles are equal. This
Yeah.
is a congruence which is called as SAS, side angle side.
Mm-hmm.
Similarly, there's a congruence in which there could be two angles equal and a side equal. So we could be given this angle is equal to this is equal to this, and the side is equal. So this is called as ASA, type of congruence. An example of symmetric triangles are one small, one big. This angle is equal to this angle. This is equal to this. So obviously the third one also will be equal
Mm-hmm.
because 180 minus the sum of these two will give the third angles equal.
Yeah.
But the sides are in proportion. So can I say symmetric concept? Angles are equal, but sides in proportion.
Mm-hmm.
So the proportionality is A is to B is to C. Then in symmetric, it will be AK is to BK equals to CK, where K will be a factor greater than 1.
Yeah.
So two concepts, congruence and symmetric. So these might not be directly tested, but it's good to know.
Mm-hmm.
Similarly, there's an SSA, two sides equal and an angle equal. As the name suggests, the two sides are adjacent to each other, and the angle will be not in between them. In the first case, the angle was in between, hence SAS. In the third, it's
Mhm.
SSA.
Yeah.
Yeah.
Uh,
So congruence means angles and sides are equal. Symmetric means angles are equal, but sides will be in proportion. Yeah.
mhm.
Okay. So let's solve this. Okay. Related to interior angles of a triangle. In the figure shown, M is parallel to N. What is the value of S minus 2R? Okay. So let's work with what we have. Can I write that RS and right angle form a triangle? RS and right angle. They are the angles
Yeah.
of a triangle. So
Yeah.
hence RS plus 90 equal to 180, and hence
Mhm.
R plus S equal to 90.
Yeah.
From now on, I'll write directly because I know one is a right angle triangle, so the sum of the other two is 90. You can
Mhm.
also write it directly. Yeah.
Yeah.
Also, we know in triangle ACB, A is 60, angle C, which is ACB is U, and CBA is T, right?
Yeah.
Now, this and this sum will be what?
Which
U
in which
plus
one?
T will
Oh,
be 120. Yeah.
yeah.
Okay. Can I also say that what is the angle T here? Should be 50, right?
50. Yeah.
Yeah, because of this setup. So this angle is equal
Mhm.
to this. So T is 50, which means we know what U is.
Yeah.
70. If we have U, we know what S should be. S plus 50 plus U should be equal to 180. From this, but U is 70. So S is 60, correct?
Yeah.
You could have also directly found S, by the way, without doing any of this. The alternate angles 60. Shortcut. So can I say these two angles will be the same in a transversal setup? This is
Yeah.
S, this is 60, so S could have been 60 directly. And if S
Yeah.
is 60, we know R is 30. And if R is 30, S minus 2R will be 0. Yeah.
Yeah.
So this is shortcut. So always in this kind of a problem, to solve it faster, look at alternate angles. Since we know M and N are
Yeah.
parallel, we can use the transversal setup. So S
Mhm.
should be equal to 60. So R will be 30 and S minus 2R will be 0.
Yeah.
Yeah. So
Yeah.
this is on interior angles. Okay, another question. In the triangles above, xy is equal to xz. Okay, so let's mark xy equal to xz and st equal to tu equal to su. So this looks like an equilateral triangle. the second one, and the first triangle, can I say two sides are equal, but the angle of one side is 60, so the other will also be 60, right? So the
Yeah.
corresponding angles are the same for an isosceles triangle. And if these two are 60, x, small x will also be 60, which means
Mm-hmm.
even this is an equilateral triangle. Which means both of these, x and y, are 60.
Yeah.
So are these congruent or are these symmetric?
Symmetric.
Symmetric, because we are not given the relationship between x, y, and
Yeah.
st. So they are symmetric, but in a symmetric triangle setup, the angles are the same.
Yeah.
Corresponding angles are equal.
Yeah.
Okay. Next one. Quant comparison question. Quantity A is AB and B is BC. And the angles are given, some of them in terms of variables. So
Mm-hmm.
this looks like a simple setup. Summation of the angles is 180, which means 2x minus 6 should be 180. Two x is equal to 186. So x is 93. So this is 93 and this is 43, right?
Mm-hmm.
Now they want us to compare AB with BC. Now the angle in the same triangle, if it's a larger angle, the side opposite to the larger angle will also be larger.
Yeah.
So can I say BC and AB? The angles opposite to BC, angles opposite to BC is 44 degrees and the angle opposite to AB is 43 degrees. So can I say
Yeah.
hence the length of BC will be greater than AB
Yeah.
because the opposite angle is higher. So this is the rule within a triangle. Within a triangle, the side opposite to a larger angle will be larger.
Yeah.
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 Okay. Another question. In triangle ABC, so let's draw this. Angle A measures 7 degrees less than half the measure of B. So can I write A as B by 2 minus 7?
Mm-hmm.
And angle C measures 49. Then what is the measure of A? So now we know A, B in terms of B, and we know C. So
Mm-hmm.
can we say what is A plus B equal to 180 minus 49? 131. A plus B plus C should be equal to 180. So A plus B should be 180 minus 49. And we know what A is, B by 2 minus 7 plus B should be equal to 131. So 3 by 2B is equal to 138. This is divisible by 3 because the sum of digits is 3, is divisible by 3. So what is B? 46 into 2. 92.
Yeah.
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 Okay, so B is 92. So what is A? B by 2 minus 7, right?
Mm-hmm.
So A will be B by 2 minus 7, which is 46 minus 7. So that is 39.
Yeah.
Okay.
Mm-hmm.
So a bit of linear algebra there, but simple.
Yeah.
All right. The next section is on area and perimeter. So area of a triangle in GRE will be tested mostly on A equal to half B into H, base into height.
Yeah.
Yeah. So for instance, in the first diagram, the height is inside. In the second diagram, the height is one of the sides. And in the third diagram, the height is outside the triangle.
Yeah.
So that happens when one of the angles of the triangle is a obtuse angle.
Mm-hmm. Yeah.
Yes. There is one more formula which you can note. Might not be tested, but good to know
Mm-hmm.
for complex problems. So that is equal to root of areas can also be written as root of S into S minus A, S minus B, S minus C, where S is semi-perimeter. And as the name suggests, semi-perimeter means A plus B plus C divided by 2, which is A plus B plus C's perimeter divided by 2.
Yeah.
So that's semi-perimeter. This is another version of the area of a triangle.
Mm-hmm.
Yeah.
Yeah.
All right. Let's see some of the setups. So your perimeter of any polygon here, it's a triangle, but any polygon will be the sum of its sides. And
Mm-hmm.
can I say what is the perimeter here? 10 plus 10 plus 12, right? So can I write it as 32? And the area here will be half base into height. Base is 12 and height is 8. So half into 12 into 8,
Yeah.
48. Okay, next.
Yeah.
All cool here?
Mm-hmm.
Okay. All right. A question. Area of triangle ABC is 6x. So ABC is 6x. Should also be equal to half base into height. So what is the perimeter of ABC? Now we know that AC is 9 and AB is 5. We do not know what is BC. Can I also say that there is a perpendicular drawn from A to BC? So BC can be regarded as base. And
Yeah.
this perpendicular is nothing but the height, correct?
Mm-hmm.
Basically, we need the base. So can I write this as 6x equal to half into base into height? Height is x.
Yeah.
And hence base is equal to 12. So now since base is 12, we know the perimeter of a triangle ABC is equal to 9 plus 5 plus 12, 26.
Yeah. Yeah.
Yes?
Yeah.
Okay. Next, a slightly more complicated problem. So we've been asked area of a triangle UVW. In fact, it's a statement. Area of a triangle UVW is greater than area of the triangle XYZ. And UX equal to WZ. UX is equal to WZ. Pan. Okay. UX is equal to WZ. Yeah.
Yeah.
And we know UVW is greater than XYZ. So is TV versus YW, which is greater? Can I say that is height 1 versus height 2?
Mhm.
As soon as they are comparing heights, it means they are comparing areas. Area is
Yeah.
given, they are trying to find the relationship between heights. So we need to use the area formula. So area of
Yeah.
UEW is what? Half into base into height. Base is what? UW and height is what? H1. And area of triangle XYZ, which is this whole triangle, half into base is XZ and height is H2. We need relationship between H1 and H2, if possible. Now we also know that area of UVW is greater than XYZ. So can I write this greater than this? So all that we have to do is to find H1 and H2, we need the relationship between UW and XZ.
Yeah.
Now they're saying UX is equal to WZ. Okay. But can I
Yeah.
say this XW is common between the two triangles?
Yeah.
This is common between the two triangles, right?
Mhm.
So can I say that UW is equal to UX plus XW? So UX XW and what
Yeah.
is XZ? That is equal to WZ plus XW. Now obviously these two are the same. And can I say UX is also equal to WZ, which means both
Mhm.
are equal. So if both are equal, they can be eliminated and hence H1 is greater
Yeah.
than H2. So answer is A. Quantity A is greater than B.
Yeah.
Yeah, so we used the area of triangle setup
Mm-hmm.
as half base into height. And then the relationship between the triangles were given, the areas of the triangles. And somewhere we found that the bases are also equal for the two triangles, which means the heights will be corresponding to their areas in relationship.
Yeah.
So area of one is higher than the other, so the height of the first one will be bigger than the height of the second one.
Yeah.
Yeah. So this is a slightly more harder problem, wherein you have to realize that this is a common side.
Yeah.
Okay. Another question, last one. An equilateral triangle has three equal sides and three equal interior angles, obviously. They are
Mm-hmm.
just defining what an equilateral triangle is. We know that. Height of an equilateral triangle is root 3 by 2s. So height is root 3 by 2s, where s is the side, length of the side. Length of each side of
Yeah.
an equilateral triangle is 4 root 3. So the side is 4 root 3. So we know h is a function of s, which is the side, and we also know the side
Yeah.
is 4 root 3. So what is h? Root 3 by 2 into 4 root 3. So can I say 2 into 3, which is 6?
Yeah.
So now we asked the perimeter of ABC. So that is 3 into s, which can I write it as 12 root 3, because s is 4 root 3.
Yeah.
And what is area of triangle ABC? Half base into height. And the base is the side here. So half
Yeah.
4 root 3 into height, which is 6. So this is also equal to 12 root 3. So the answer is equal quantities. Both quantities are equal.
Yeah.
There's one formula which I want you to remember. So that is on the area of equilateral triangle.
Mm-hmm.
The formula is root 3 by 4 into side square. So if the side is given, directly you can find the area of an equilateral triangle without having to find the h or the height.
Mm-hmm.
So root 3 by 4 s square is the area of an equilateral triangle.
Yeah.
So here we knew the height they have given us, but not always will they give us.
Mm-hmm.
And how did we get this? If you see, they have given us the height here,
Yeah.
root 3 by 2s. So can I write area as half into base into height? Base is s and height is root 3 by 2s. So this becomes root 3 by 4s square, which is what I've written here.
Mm-hmm.
So even if you do not know the height, you can still find the area of an equilateral triangle since you know the side.
Yeah.
Yeah, so these are some basics on three things which we did today within geometry. We did
Yeah.
lines and angles. We did interior angles of a triangle, and we are at area and perimeter of a triangle.
Mm-hmm.
So in the next session, we'll be doing polygons. We'll be continuing with triangles, finishing this, and we'll be doing quadrilaterals, polygons, and other
Yeah.
hybrid figures. We move on. So today was more on along
Mm-hmm.
and some of the easy to medium applications of the same. Yeah, all good.
Yeah. Yeah.
All right. So see you tomorrow,
Mm-hmm.
late evening,
Yeah.
same time,
Yeah.
which we usually have.
All
Yeah.
right.
All right.
Mm-hmm.
How was the RC,
Thank
by the
you.
way? RC was good?
RC, I still had issues writing the map, actually.
You took 5 minutes, right, to
Mm-hmm.
read the passage and to create the map.
Yeah,
Yeah. Okay. So what we'll do is I will go through, I've not gone through your RC. I'll go
yeah.
through it today and we'll discuss tomorrow. And in the
Mm-hmm.
meanwhile,
Perfect.
let me send you a
Yeah,
bunch of 5 to 6 more RCs, which we can
yeah.
discuss tomorrow. So
Mm-hmm.
tomorrow we'll be doing a longer session. We'll have to discuss all the
Yeah.
RCs, which I'll be giving you, and we'll be completing whatever we can from geometry. So as you can see, this is a large slide deck, around
Mm-hmm.
100 plus, and there are
Yeah.
more PPTs also. So this is just one of them. So this
Mm-hmm.
will complete at least um, one portion of the syllabus, but then
Yeah.
there is also coordinate geometry, and there's
Yeah.
also 3D geometry which has to be done apart from this. So this
Mm-hmm.
PPT is related to 2D geometry.
Yeah.
Okay, so two-dimensional geometry. We'll be doing some solids like prisms, cubes, cuboids,
Mm-hmm.
cylinders as part of 3D geometry, and then
Yeah.
a simple area of geometry which is coordinate geometry related to X and Y axis. So three
Mm-hmm.
major areas within geometry that we need to do.
I went over the slides here today
Yeah.
that you sent earlier, and there was nothing about prison geometry.
There was nothing on.
Prison geometry. There was only cuboids and cylinder.
Okay, there is nothing on 2D geometry, is it?
No, 3D prism
All 3D.
geometry.
Okay. So
Yeah.
let me send you something which is for 2D geometry
Mm-hmm.
and basics.
Yeah.
Yeah, so you
Okay.
can read those notes, you can solve the RCs, you have enough
Mm-hmm.
at hand.
Okay.
Yeah. And I'll see you tomorrow then.
Okay.
Thank
Thank
you.
you.
Take care.
Bye.
Bye.